Today's lesson comes from section 11.1, day 4. Our objective is to rationalize radical expressions. So at the top of the page, again, I have some things that you're going to want to keep in mind. So the number one rule is that you cannot leave a radical in the denominator. In order to get the radical out of the denominator, we're going to do two things. First, we're going to look for perfect squares. If we have a perfect square, and then we can just take the square root of it and there will be no radical left. Or if there's no perfect squares, then we're going to multiply the numerator and the denominator by the radical that's in the denominator. Now the reason for this is because if you guys remember your properties, if I took the square root of 8 and multiplied it by the square root of 8, that gives me the square root of 64. What is the square root of 64? Well, it's 8. So if I take the square root of 8 and multiply it by the square root of 8, or multiply it by itself, I get a number that is no longer underneath the radical, which would satisfy my goal of having no radicals in the denominator. So let's try this with a few problems. Our level 1 questions won't actually require us to get to the second step at all because they're going to have the perfect squares that we need. So level 1, our first problem, is the square root of 5 over 49. 5 doesn't simplify with 49 at all, so I'm going to split this into two little radicals and take it as the square root of 5 over the square root of 49. And just like I said, this one is going to have a perfect square in the denominator, so I simplify that. I get the square root of 5 over the square root of 49 is 7. We've satisfied our main goal for the day in red. There's no radical in the denominator, and it's as simplified as it gets, so our answer is radical 5 over 7. So 1a for you to try is the square root of 3 over 64. Okay. Question number 2. I could give you the square root of 12 over 75. Right now, it looks like there's no perfect squares. However, I'm looking at 12 and 75 and I'm saying, oh wait, they're both divisible by 3. So I'm going to start by simplifying. And this is equal to the square root of 12 divided by 3 is 4. 75 divided by 3 is 25. So it's equal to the square root of 4 over 25, which is equal to the square root of 4 over the square root of 25. And I happen to know the square root of 4 is 2. The square root of 25 is 5. And so my answer is just 2/5. So 2a for you to try is the square root of 8 over 18. Alright, so that's us looking for perfect squares. Now level 2 is going to get a little more challenging because there's not going to be any perfect squares that we can work with. So we're going to have to work on our second step, which means we're going to have to multiply both the numerator and the denominator by the radical in the denominator in order to get rid of that radical. So question number 3 is 2 over the square root of 5. Again, I'm looking at this. Nothing simplifies because it's not all under the radical. And then the square root of 5 is not a perfect square. So I'm going to multiply both the numerator and the denominator by the square root of 5 because the square root of 5 is the radical that I see in my denominator, and I want to get rid of that radical. So if I multiply the square root of 5 times the square root of 5, I notice in the denominator I get the square root of 25, which ultimately will give us 5, and that'll have no radical in the denominator. And then I look at my top and I see I have 2 times radical 5, which is 2 radical 5. And 2 radical 5 doesn't simplify at all, so I just bring that over. And so my final answer is 2 radical 5 over 5. Again, multiplying radical 5 times radical 5 gives me the square root of 25, which is 5. And so I've satisfied my goal to have no radicals in the denominator. I'm looking at this final answer and I'm saying, oh, it can't be simplified because nothing inside can simplify with anything outside. So I know this 5 and this 5 cannot be simplified together because they're complete different entities. Remember, one of those 5s is staying at home all by himself, and the other 5 is outside on a date. Okay? And then the 2 and the 5 are both outside on dates, but they don't simplify at all. So I know I'm good. Finish with that problem. So 3a for you to try is the square root, or let's do 3 over the square root of 11. Okay? And problem number 4 is the square root of 27 over 2. And I'm looking at this, I'm saying to myself, 27 and 2 don't simplify at all. So I'm going to break this into two little radicals. So this is the square root of 27 over the square root of 2. And the square root of 2 is obviously not a perfect square, so I want to get rid of that radical in the denominator. So I'm going to multiply both the numerator and the denominator by the square root of 2. And I'll start by working with my denominator. The square root of 2 times the square root of 2 is the square root of 4. And then I'm not going to actually multiply the 27 and the 2 by each other because I know that in the long run I just want to go ahead and break them back down again. So in the numerator, I'm just going to do 27 times 2. Okay, and then I'm going to do some side work over here. And I'm going to break down 27 times 2. I want to make my factor tree so I can simplify that because 27 is a pretty big number, and so I'm saying to myself, I might have some pairs. So I break down 27 into 3 and 9. The 9 breaks down into 3 and 3. And when I look at this, I see that I have a pair of 3's. So I'm going to pull them outside of the radical. And then left at home is a 3 and a 2. And I know that anytime I have two numbers left at home, I multiply them. So inside the radical is 3 times 2, which is 6. So that was my side work just to tell me what my numerator simplified to be. So I have 3 radical 6, and then I simplify my denominator. The square root of 4 is 2. And so my final answer for this one is 3 radical 6 over 2. Again, I'm going to look and see if the 3 and 2 can simplify. They don't, so I know that I'm done. Your problem 4A is, let's do the square root of 32 over 5. Okay, and problem number 5, last one from this example set. Let's do the square root of 3 over 21, and I personally think this one's a little bit easier than the last one. So the square root of 3 over 21. I want to simplify this first because I see that I can. 3 and 21, both of them can be divided by 3, so this is the square root of 1 over 7. And then I'm going to break this down into two little radicals. This is the square root of 1 over the square root of 7. And I do know the square root of 1, so that's just 1 over the square root of 7. And now my problem here is that I have the radical in the denominator. So in order to get that out, I have to multiply by it in both the numerator and the denominator. So I'm going to multiply by the quantity of the square root of 7 over the square root of 7. Multiply my numerator across. 1 times radical 7 is 1 radical 7. In the denominator, the square root of 7 times the square root of 7 is the square root of 49. And then I'm going to simplify. So 1 radical 7 is really just radical 7. The square root of 49 is 7. And I look at my final answer and I've satisfied my goal. I have no radical in the denominator. It's okay if it's in the numerator. And then I can't simplify anything because numbers inside the radical do not simplify with numbers outside of the radical. And so my final answer is the square root of 7 over 7. And your 5A problem is the square root of 6 over 18. Don't forget to simplify first when you're attacking this problem. Okay, and two more questions actually. These of course are level 3 questions. So problem 6 from level 3 is 3 radical 5 over 2 radical 8. And this one looks trickier because I don't just have a radical in the denominator, I also have a number outside of the radical. But again, I don't care about the 2 at all. The 2 is not bothering me. The main issue is the 8. So I'm going to go ahead and I'm going to start by simplifying that 8 because I know that the 8 can actually be broken down further. So I'm going to break down the square root 2 radical 8 from the denominator and see what that ends up being. So 8 breaks down into 4 and 2. 4 breaks down into 2 and 2. Cross off my numbers that have been used. I have a pair of 2's. Those get pulled out and multiplied by the 2 already outside, so we have 2 times 2 outside the radical. And inside the radical, I have a 2 left at home, so that 1, 2 stays home. So my denominator actually simplifies to 4 radical 2. So this is equal to 3 radical 5 over 4 radical 2. And that made my radical a little bit smaller, but it hasn't satisfied my ultimate goal, which is to get it out of the denominator. So I'm going to have to multiply by the quantity radical 2 in order to get rid of it. So I'm going to multiply both the top and the bottom by radical 2. Excuse me. And so the top is, I multiply the numbers outside, so 3 times there's an invisible 1 here is 3. And then I multiply the numbers inside, 5 times 2 is 10. And then in the denominator, I have 4 times my invisible 1, which is 4. And then I multiply the numbers inside, and 2 times 2 is 4, so I have 4 radical 4. And I know that the square root of 4 is 2, so instead of the square root of 4, I'm going to write 2. So this is equal to 3 radical 10 over 4 times, again, instead of the 4, I'm going to write 2, because the square root of 4 is 2. And before I even multiply those out, I'm looking and I'm saying, hey, I have a 2 in the numerator and a 2 in the denominator. Both are outside the radical, so I can simplify them. So I'm going to divide out those 2's, and all that's left in the numerator is radical 10. All that's left in the denominator is 4, and so my final answer is radical 10 over 4. Okay, your 6A problem for you to try is 4 radical 2 divided by 5 radical 3. And we have one more example. That's problem number 7. Let's do negative 2 radical 7 over 7 radical 14. And this one's a little bit different than the last one because I'm looking at 7 and 14. Those are my two numbers under the radical. And I see something in common with them. So if I can split up a radical from being one big radical into 2 little radicals, then I can also take 2 little radicals and make them one big radical. And I'm seeing that the 7 and 14 have something in common. I could probably simplify them. So my goal here is I'm going to go ahead and combine those together. So this is negative 2 over 7 times the square root of 7 over 14. And 7 over 14 simplifies to 1 over 2. So this is negative 2 sevenths times the square root of 1 over 2, which I can break that down into 2 little radicals again. And so I have negative 2 radical 1 on the top over 7 radical 2 in the denominator. The square root of 1 is 1, so this is really just negative 2 times 1. So my numerator is negative 2, and my denominator is 7 radical 2. Now, don't be caught in trying to simplify the 2's together, because that 2 is outside in the numerator, the 2 is outside the radical. It cannot be simplified with the 2 that's inside the radical. So, to get that radical out of the denominator, I'm going to multiply both the numerator and the denominator by radical 2. And so in the numerator, I have negative 2 radical 2. And in the denominator, I have 7 times the square root of 4. And I know that the square root of 4 is 2, so this is really negative 2 radical 2 over 7 times 2. Now that 2 is no longer in the radical, so I can go ahead and simplify the 2 in the numerator with the 2 in the denominator. And I'm left with, in the numerator, negative radical 2. In the denominator, 7. And so my final answer is negative radical 2 divided by 7. Your problem 7a for you to try is negative 3 radical 5 over 5 radical 15. Remember, 5 and 15 have something in common, so you're probably going to want to make one big radical and simplify that first, then start breaking down from there. And with that, I'm going to leave you with your fun fact, which is that a jiffy is an actual unit of time, referring to 1/100th of a second. All right, have a good night.